Now it's working. Okay. Written homework. Next week is our exam on Thursday. So instead of handing in homework on recitation, you're going to hand it in class on Wednesday. Okay. Instead of handing in your homework in recitation, next week on Wednesday. And web work we're going to put on pause. So today's was the last one for maybe some time. And because of that, I'm going to put more problems here. So if you've printed this out, if you've already done it for next Wednesday, just know that I'm going to add to that list. Okay? So I'm going to add to that list. When I've added to the list and it's finalized, then it'll be starred and it'll say finalized. Okay? This is the final list. Okay? So as long as it looks like that, expect more problems for next Wednesday. And then our exam will be Thursday. What else? Don't forget the class videos. Try to watch those like the same day as class or the next day. That's going to be the best. You're going to get the most out of those to consolidate and to get the learning in there, memorized, learned, instead of just having it fall out of your brain. Okay? But they're all for the whole semester. They're all available. Okay? Questions on announcement type stuff? Yes, sir?
You said the test is on Thursday.
Thursday.
Does that mean that it's sort of like the pre-test?
Just like the pre-test procedure. You're going to bring your Sun card, go to ECA 21 between 10:30 and 6:30, and then you have as long as you want to work on the exam. But they'll collect them. They collect the exams at 8 p.m. Okay? So if you get there at noon, you got 8 hours to work on the exam. Have a ball. I would guess the most of you will take between probably around hour to hour and a half-ish. Okay? Some will be less than an hour. Some like to take their time. You may be there almost 2 hours. But I would say most is going to be around the hour 15 mark. Yeah, recitation. We'll still have recitations this week. Yep. Other questions? All right. So I want you to, while I take roll, I want you to go to this page in your page 88. I want you to work numbers 3 and 4 on page 88. That's the whole page. If you happen to get finished before I give you other instructions, then you can turn back and work on numbers 1 and 2 on the previous page. Okay? But I want you to start with page numbers 3 and 4 on page 88 as I take roll. Okay? Oh, and so let me just say, when you're turning in written homework, the important thing about written homework is your written explanations, right? They're going to ask you to explain your reasoning. So you want complete sentences, and you want it to be accurate reasoning like what we're working on in class. Okay? Now for this, they also ask you to explain your reasoning. If you just want to put your answers and then kind of have a conversation about what things mean, that's fine. So try to move through this at somewhat of a good pace rather than trying to word a certain sentence perfectly and getting stuck at one part. Okay, so I want you to kind of try to move through as many of these as you can. Use the chance, the explanation, this can be verbal for this worksheet, okay? Okay, so let's pick on a few of you here and see. I'm more interested in interpreting the notation than I am the numbers. So you can check your numbers. I put the numbers up there. You can check those. But what I want you to do, I'm going to point to something and ask you to tell me what it represents. Okay? And that's the name of the game here. So, who's up? Scott. Did I call on you last class? No. Okay, you're up. So tell me what. Let's just go right to this one right here. So that 2 times f of 4, what would it mean?
Price of 2004 year cars.
He said the price of 2 cars that were in 2004. The price of 2 cars in 2004. What do you think? Is that what that would mean? Yeah, good, okay. What about Zachary Wilden?
Yeah.
Next one. So how could you interpret that expression right there? What would that mean?
That's the price of car in 7 years after 2000 plus $1,250.
Okay, so can we do it without saying plus? What would it just the whole number mean? So can you get kind of what would the whole number mean? Whose lips are moving? You in the gold shirt? Oh no, the gray shirt back there. Okay, yeah. What you said was correct,
Yeah.
but we want to think of what would that whole value mean as one thing rather than it's this value plus this value. Does that make sense? That's right.
$1,250 more than what a car cost in 2000.
She said $1,250 more than what a car cost in 2007. Yeah, that does it. That's good. Yeah. So $1,250 more than what a car cost in 2007. Okay. Where's Tanner? You're up. Tell me about this last one here. So we want to do it without minus or without subtract or difference. So what does that expression mean right there?
The change,
Okay. What change?
the change in the price of options for
Okay, the change in the price of the car. That's right, change in the price of the car. So can we be more specific? That's a great start. Okay? From 2003 to 2006. Isn't it from 2006 to 2003? So in order to find a change in a value, you take the what quantity first? Final value of the quantity minus the initial value of the quantity. So he said the change in the price of the car from 2003 to 2006. Agree? That's it. Okay, I want you to represent the change in the price of the car from 2002 to 2007. Go. So over here in the red, represent the change in the price of the car from 2002 to 2007. Adrian, when you're ready, you're up. So take your time, but when you're ready, I'm not asking for the answer. I'm asking for you to represent it. I'm not asking for a number. I want you to represent it. What? Any idea? Okay. How about right next to him? What's your name? Yakujo. He wants f of 7 minus f of 2. What do you think? And now let's find the answer. Does anyone find the answer? Just shout it out. 955? And we said that was the change in price from 2002 to 2007, right? Now, we could have done that faster by saying f of 5, right? Because 7 minus 2 is 5. So we just do f of 5. Okay. Well, so countless of my past students have tried to do things this. It's a very easy trap to fall into, so that's why I want to point it out. What does f of 5, what does that mean? Yeah, Fernando.
Price of a camera at 2005.
The price of a Camry at 2005. And what is the price of a Camry at 2005?
The price of a camera at 2005 is $19,295.
Okay. Totally different. Look, f of 5 is $19,295. And what's f of 7 minus f of 2? Totally different values, right? Because they have totally different meanings. The first one is the change in price from 2002 to 2007. This one is just the price in 2005. Okay, so watch. I just want to point that out. It's a very easy trap. Many of your predecessors have fallen into. So I'm trying to point it out to you. These are not equal. F of 7 minus F of 2 is not the same meaning as F of 5. There could be situations where the value turns out to be the same, but the meaning is always different, and most of the time the value is different. Does it make sense? Okay, any questions on number 4? Is there a question that you have about number 4? Or did that go okay? Here's your chance. If there's no questions about number 4, then let's go back and do number 1. So I want you to do, on numbers 1 and 2, just A through D on both. A is an apple through D is in dog on both. Numbers 1 and number 2. Okay, I want you to, number 1, I want you to get a partner and prepare answers and explain to each other why you did what you did. Just talk it out. Talk out the answers to number 1. So that means there will be 40 conversations. Find a buddy. Talk through number 1, A through D. Okay, rapid fire. Where's Carter? Part A. Explain what G of R represents. What is?
It says G of R is the name of the function, which represents the input value of the radius of the line.
So G of R represents the input radius of R.
Yes.
Okay, what do we think? Let me ask Cujo. We already asked. Where's Edward Morris? Edward, do you agree with what he said? G of R is the input value of radius. Agree with that?
No.
What do you think?
G of R is the result of the area.
So say the whole thing together.
So G of R is the resulting area based on the input of R radius.
Okay, so yeah, so it's G of R altogether is an area, right? It's the area of a circle when? When the radius is R. It's the area of the circle, that whole thing is the area of the circle when the radius is R. Okay, so tell me about, where's Christian? You're up. So how would you represent the area of a circle whose radius is 3.5? This one right here. So I want to represent the area of a circle whose radius is 3.5. Just the first. This is 3 different questions. I'm just asking about the first one. So represent an area of a circle whose radius is 3.5, period. F of 3.5? What's this function called again? What's the name of it? G of 3.5. Okay? Next one, part C. Adam, you're up. Tell me what that expression means.
That means when my radius, my input 4.9, my radius is 4.9, then my circle area, that is G of 4.9, 75.43.
What do you think about what he said? Nailed it, right? So this is the area of the circle. It will be 75.43 when the radius is 4.9. Okay? Finally, Crystalie. I don't think she's in the class. Elizabeth Phillips. Where's Elizabeth? In the corner. How about this next one? What does it mean to solve this? So as solving for R, what would it mean? Which radius would we be finding? Right, so you're going to be finding the radius of a circle whose area is 141.026. Why? Because that's equal to G of R. The area is 141.026. Questions on these? Anybody have a question? Same thing, 2A through D. Work them with a partner. 2A through D. And F. You can do A through D and F. Just don't do D. You can skip E. If you need a moment to think by yourself, that's fine. But then eventually you'll be talking, sharing with the person next to you. Yeah, talk through them with the person, with your partner. Talk through them. Okay, where's Jonathan Clark? All right, Jonathan, you're up. Represent the population of Blacksburg K years after 1990. Say it again. H of T plus K? Patrick, Cowger. Where's Patrick? Patrick here?
Yeah.
You agree with that? You want H of T plus K?
No.
What would you think it is? H of K. All right, what do we think? What is the input into this function? No, just in general. The number of years after 1990 that's the input. And so if we want it to be the input equal to? Okay, right? So we were saying K years after 1990, that's exactly what the input is. So instead of H of T, we have H of K. So H of K. All right, the meaning of H of K plus 3. Where's Justin Rayner? Tell me.
So there'd be a population in a town K plus 3 years after 1990.
The population of the town, K plus 3 years after 1990. Nailed it. Okay, cool. Where is Penny? Next one. M years. Oh, sorry. 765 more than the population in the year 1996. So
That means he equals H of T plus 765.
H of. So what is the population in the year 1996? H of what?
H of 6.
H of 6. And then do we want to add 765 inside or outside? Because we got the population in 1996, and we want 765 more than that population, so we're going to add it on the outside. Okay, D. Angelica. So is this the change in population from M years after 1990 to M plus 7 years after 1990? Is that what that is? Some are nodding, kind of. Is that what you have, or is something different? Okay, what's another way, besides saying we start M years after 1990, and we have the change in population until m plus 7 years after 1990. What would be another way to interpret that? Can you think of another way to say that? So, starting m years and ending m plus 7 years. Think of a different way to say that what that change of population is? Fernando.
The change from 7. Okay. The change from 7 years after n. No, the change from n years to 7 years after n.
Okay, yeah. What is the change in the number of years? What's the change in t in this case? M plus 7? 7. We have a change in time of 7. Do you see that? We're at m years since 1990, and then we're 7 years after that. So that expression represents a delta t of 7. Do you see that? So how can you use that idea that this period of time is 7 years to describe that? Anyone else? Want to give it a shot? Change in population. You want to try again? Yeah. Delta M? No, M is a certain number of years after 1990. And then we have a delta T, right? Because that input quantity is T, so we have a delta T of 7. So what change in population is it? But I'm asking you to interpret the expression in a different way, to say what it means. No, so I'm asking you to explain what that expression means in a different way. Yeah. Right, starting m years after 1990. Yeah, that was it. So it's a change in population over a time span of how long? 7 years, starting m years after 1990. Do you see? So that's a different way to do it. And that kind of gets the idea of this delta t of 7, right? Delta t of 7. Rather than saying from m years to m plus 7 years, we can say, oh, it's a 7-year period. So it's a change in population over a 7-year period, starting m years after 1990. Okay, questions on number 2? Yeah.
This is kind of a semantics thing. Usually, as far as as far as F, in F, when they're denoting a change that doesn't include an input, so basically a change to the function itself. So 5,
Here?
Yeah, it's usually written before. So with C, when you wrote 765 afterwards, I mean, can you do that and it still wouldn't be that big of a deal? Or could you put it beforehand? So H plus 765 of 6.
You're saying this?
Kind of.
Totally the same. No difference. Okay.
So that's cool if I write
Totally the same and both totally valid. Now this is 5 times the population k years after 1990.
Yeah, and basically what I was saying was could you plot that file on the other side?
I usually put coefficients, constant coefficients in front of expressions, but again, both perfectly fine. 5 times the population k years after 1990. Okay, so another exercise for you. Okay, here we go. So this is 2 functions that have to do with kind of a construction or industrial workplace. They're hiring people, they're hiring different numbers of people, and they're changing the lengths of the shifts based on the number of people, okay? And then over time, how long the shifts are is determining how many accidents there happen to the year. So the function f is given the input of the average length of their shift, it predicts how many accidents you'll have. That's to be per year. So very easy to fix. There we go. Okay. So length of the workday over time results in a longer day, results in more accidents. Function g is how many workers they employ per day, and then how long the resulting shifts are. So more workers, they can give them shorter shifts because they have more of a workforce. So that's your function F and G, input, output, and I've got a series of questions for you. Okay, so this is kind of moving on to the next idea that we want to talk about. So answer the questions. You can work together, take a couple minutes, and answer these 4 questions. Go ahead. You understand what we're doing? This should go fast. Okay, I'll make one lap around for questions. Yeah, so each one answering the number and then expressing the position. Makes sense. That'll be next. Yeah, if you can do, yeah, that'll be next. So go ahead. Daniela. Where's Daniela? You're up for number 1. So, how many accidents are expected when the shifts are 11 hours long? What's that? 10 per year. And how'd you represent that? Nice enough. F of 11, this is what you said. F of 11 equals 10. Agree? Nailed it. Okay, cool. How about Frank? You're up. Number 2. And tell me what that whole thing means. G of 70 equals 11.5, so tell me what that means.
So there are 78 each day. There is an average like 11.5 hours.
Right. Good. Okay. Next one. Little bit different. Michael Dumas. Michael here? All right, Michael. Tell me about this next one. So now what's the average length of shift, approximately, in a year where you might see 7 accidents? Can you represent that?
7G,
G of 9?
yeah, 10 total B9,
Which function is it?
G,
Average length of shift, number of expected accidents. That's F, right?
yeah,
Is that it? And so the value 9, which is the answer to this question, is what? What does that represent? Is that a number of expected accidents? Or average length of the shift? Average length of the shift. Okay, so now number 4, this is kind of the new idea. If you knew there were 65 workers hired each day, and that over the course of a year, how many accidents would you expect? So, where's Ryan? Mount. Ryan Mount? Okay, so tell me the process, not just the final answer, but what process did you go through to get that accidents expected?
So you plug in how many workers you have in 65,
Into?
how many hours they're going to work.
And which function are you using to get that? Using G function or F function?
I'm using G.
G, right? So with G,
How many hours they're going to work.
right?
And then you would take what's the output of that, which is 12 hours.
Okay.
And plug it into F to find out how many accidents per year,
That's right.
which would be 13.
So what happened? The output of G became the input of F. This is the key. The output of G now became the input of F. And so where a function is a one-step process, now we're taking a two-step process to answer this question. How many accidents expected? 13, right? Okay, so take me through the process. Somebody new. Where's McLean? Take me through it for the next one. So 100 workers, what's the process you'd go through to get? Okay, which is? 8 what? Okay. So you come over here and put in an input of 8, and you get 6 accidents per year. Okay, so now what I want you to do, so this is this process of you're taking the output of G, and you're making it the input of F. How do we represent the output of G? How do we represent the output of G? G of, in this case, G of what? In this first one? 65. Now, that's the output of G with 65 workers. How do we make that the input of F? F of that, right? So now that G of 65 takes on 2 meanings. It takes on 2 roles. It's the output of G. It's also the input of F for this 2-step process. So what would this one be? The red one. G of what? G of 100. That's the output of G. And we took that output of G, which was 8, and we made it input of F. Okay, I got just one more thing. Sorry. So this now is the notation for a 2-step process. I got one more thing. Sorry, I got one more thing. Don't pack up. This is the notation for a 2-step function process where you put a value, crank out an output, and then that output becomes the input of the next process. So these are quick questions. They take a little bit to read, but these are quick. So do 5 and 6, numbers 5 and 6. Okay, Daniel Wallace. Where's Daniel? Daniel Wallace. Come on, help us get out of here. Not here? All right, where's Taylor Davis? Taylor, you're up again. FG of 80. Does it make sense?
Yes.
And what does it mean?
It means how many expected industrial accidents per year on your
Good. So it's how many accidents you'll have because it's the overall, it's the output of F, right? It's the output of F, but it's the output of F when we have 80 expected workers. What about G of F of 9? What is F of, just do F of 9. What does F of 9 mean? 80 expected accidents, okay? What are we trying to do with that? Put it into G. What is G expecting for its input? For workers. So you're handing G a number of accidents. It wants for its input number of workers. So it says, sorry, that's not my function, right? That's not my function. I'm rejecting that. So G can't do it. And so this does not exist, right? It's invalid. It's an invalid argument because the function of G is to take a number of workers. We're trying to give it a number of accidents. See? So it doesn't have a real world meaning. It doesn't exist because the function of G is to take number of workers, not number of expected accidents. Have a great weekend. I'm going to add problems to Wednesday's homework.